Hello, I'm Patty Simpson with Simpson Math. In statistics, we always start with some sort of question that we want to know the answer to. And the way we answer that question is we collect data on some variable. Then once we've collected that data, we describe it and analyze it. So we're doing some sort of math with the data that we've collected. In this series of videos, we're going to look at describing those variables, describing that data, so that we know what kind of math can we perform on the data that we've collected. So in this first video, we're going to look at the difference between qualitative data, qualitative variables, and quantitative data. So both of these have a nice root word that helps me to remember the two of them. This first one, qualitative. When I think of qualitative, I think of quality. This is the quality. Whereas in quantitative, I see that quant, or I think quantity. And that's kind of the difference between the two types of data that we're collecting. With qualitative data, or some people call it categorical data, the variable is describing some sort of attribute, or it's putting our data into different categories based upon those attributes of the population. Whereas quantitative data, we're describing a quantity. We're measuring an attribute. We end up with a count or a measurement of that attribute from the population. So here are some examples of the two. Qualitative, I think of as qualities or categories. And typically, most of the time, the data you'll be collecting are words. So you'll be collecting words that you write down as your data. For instance, here are some examples of those variables. Hair color is an example of qualitative data. So think about if I ask you what color is your hair, you might answer brown or red or purple or black or blonde. You're going to give me a word back as the color of your hair. That's a quality or a category that you're putting yourself in. Ethnic group is another example of that. Blood type. When you answer what is your blood type, you're going to answer with an A or a O positive, or maybe it's A positive and O and B minus, whatever your blood type is. The type of car that you drive, a Toyota or a Ford or a Honda, those are words that you're giving me back. They're different categories that we're placing things in. Even the name of your street, Adams and Zenith and Upshaw. Those are street names, Lincoln, you're writing down those words. They're different categories or qualities. So we call that qualitative data. There are some tricky examples to that where you're actually putting yourself in a category, but you might be writing down numbers instead. So think about zip codes for a minute. If I tell you that my zip code is 76501, all that does is tell you where I live. It gives you an area that I live in. It tells you that I live in North Temple. That's what that zip code tells you. So think about your zip code. It just tells people where your city is. What part of that city do you live in? So even though it's a number, it's not really measuring anything. It's not really counting anything. You're really just saying, I live in North Temple when you give out that zip code. So zip codes, even though they're numbers, they're kind of a tricky example of a qualitative or categorical data. Another example of that is Likert scales. Likert scales are those scales that you answer, say, each time you go to the doctor. And they ask you, on a scale of 1 to 10, how are you feeling? And you might say, well, I'm a 1. What does that 1 really mean? You're not really measuring anything or counting anything. You're really just saying, I'm in a teeny tiny bit of pain. Or maybe you answer with 9. And that means I'm really hurting really bad. So those numbers don't really mean a quantity of something. They really are a description. Other times that you might see Likert scales, when you go to like Subway and they have you call in for a survey of how they're doing, and they ask, how was your service today? And you have to type in, 1 to 5 on the phone. You're putting in a number, but that number is not actually counting, or it's not a quantity. It really means I got really good service, or I got really poor service, or somewhere in between. So when you put in that number, it really means those words. So Likert scales are most of the time an example of that qualitative data that we're collecting. Also, your student ID or your social security number, or maybe your jersey number. If I write down those different jersey numbers or student IDs, they aren't really a count of something. What that really is an identification of you. It's like you writing down your name, because it really identifies you. So those are kind of tricky examples, because when we write down our data, we write down numbers, but they really mean those different categories or different qualities. So these are all examples of qualitative data. They're mainly words that we're writing down, but they really describe a category that you're putting yourself in, or it's some sort of quality that the variable is collecting. Examples of quantitative data, remember that quantitative is quantity, it's some sort of count or measurement. So if I decide to measure the length of your hair, well, that is going to be a measurement, a count, a measurement of something, a quantity. The height, the weight, temperature, the number of children in your house, the number of books that you have, the number of cars that you own, the number of pencils. All of those are counts. You're counting things. So the number of something is an example of a quantitative data. Or the population size. Maybe I want to know the population of a town. That population size is an example of quantitative data. Notice in all of these cases, you would be writing down numbers. So with quantitative data, you're writing down some sort of a number. And that's how you know it's a quantitative, it's a measurement or a count of something. So in the next videos, we'll be learning about how we can do different math with these different variables. You can see that if you have hair color, like brown, blonde, red, I can't take that data that I've written down and add it together. How am I going to add brown plus brown plus brown? That just doesn't make sense. Whereas if I have the number of children from everybody in the class, I could add those together and maybe even do some division to find an average. So the type of math that we do as we analyze our data is dependent upon what kind of data we've collected. So we need to be able to decide a little bit or describe those variables as we go along. In the next video, we'll look at the levels of measurement for these various types of variables. In this video, we're going to look at the difference between continuous and discrete variables. So we talked about in the previous video that being able to describe our variables is important, because once we've collected our data, we need to know what kind of math can we perform on the data. And knowing if it's a continuous or a discrete variable helps us to determine what type of math we can perform on our variables. So with continuous and discrete, those two terms only deal with quantities. We're dealing with measurements or counts. And so they only refer to quantitative variables. In our previous video, we looked at quantitative and qualitative variables. All of our qualitative variables will be neither continuous nor discrete, because these two terms don't deal with those qualities or categories. They only refer to quantities. So once we've decided that it's a quantitative variable, then we can categorize it as either discrete or continuous. Discrete variables are those where our data is countable, where we are actually, each number is distinct or separate, or we can actually count in order to record our data. whereas continuous data is data that takes on a range. It can be any value within an interval. So that, or you can think of it as being measured more and more precisely. I can get in between. If you give me two numbers, I can find something out in our population that can actually get in between those two measurements. So let's look at some examples of that quantitative data that is either discrete or continuous. Here we have some examples of discrete data. Now remember that discrete is a distinct, separate, or countable data. So here the number of children that you have, you can actually go out and count the number of children. You have 3, or you have 5, or you have 7 children. You don't have 2.5 children. Well, maybe if you're counting your husband, but no, you can actually count each one of those people. So you have a countable number of children. The population size of a town is the same way. You can actually count the people there. Number of animals at the zoo, again, those are distinct numbers. Those are countable. The money in your pocket, you can take out your money in your pocket, and while that will maybe, $3.04 so that it ends up being a decimal, it is still countable. It's a distinct amount. So those are examples of discrete variables. Here's some examples of continuous variables. Weight. Weights can be measured more and more precisely, as can height, time, speed, and temperature. For instance, I might say that I'm 5 foot 5 inches, and someone else might come along and go, well, I'm 5 foot 5.5 inches. And someone else might come along and say, well, I'm 5 foot, and measure it more and more and more precisely. I can get in between the two numbers. Or like with the time, as I'm looking to see, it looks like they crossed the finish line at exactly the same time, but if I measure it more and more precisely, I can get in between 2 times. So these things can be measured with more and more precision, or the answers, the numbers, the data I'm collecting can be collected on an interval. And if I say that someone weighed 160 pounds and someone else weighed 161 pounds, there's someone out there in between that could be in between those two, 160.5 pounds. So continuous is more and more precision, whereas discrete is very countable. And all of our qualitative variables, such as hair color or type of car you drive or the breed of your animal in your home, all of those things, those qualitative data, are neither continuous nor discrete, because it just doesn't, those terms don't make sense unless it is a quantitative or some sort of quantity that we're writing down. In this video, we're going to look at the levels of measurement that our data takes on. In this series, we're looking at how to describe our variables, how to describe our data so that we know what type of math we can perform on our data. So there are 4 different levels of measurement that we're going to be looking at in this video: nominal, ordinal, interval, and ratio. And it works from the most basic math that we can do with our variables up to the most advanced math that we can do with the data that we've collected. So let's start with our nominal level of measurement. Our nominal level of measurement is going to be used, or helps describe, that data that is qualitative data. In other words, the data that we are collecting looks like words. It's names and labels. And with this data, the only thing we can do is count the number of data values that we have within a certain category. So for instance, hair color, gender, or your favorite pizza topping. So think about that for a second. If I asked you what color is your hair, you might answer brown or black or blonde. I can't take black and blonde and add them together. The only thing I can do is count how many students have blonde hair, or how many students have purple hair, or how many students have black hair. I'm just simply counting how many are in each category. I can't do anything else with that data that I've collected. So that qualitative data, where all I can do is simply count how many are in each category, is at this nominal, or the most basic level of measurement. We move up to there to our ordinal level of measurement. Ordinal level of measurement, we're also talking about our qualitative data, that data that typically when we write it down, it is words. But it can be arranged, and it not only can it be counted, like we did it back here, where we count how many are in each category, but also it can be arranged in a meaningful order. We can put them in some kind of ordinal order. So you can see that ordinal, you can see that order in it. So I can put it in some sort of meaningful order. For instance, if I ask you what type of medal did you win at the Olympics, and I write down gold, silver, bronze, I'm writing down, I could count how many gold medals there were and how many silver medals there were, but I could also arrange those in a meaningful order. Gold is better than silver, is better than bronze. A lot of times we see this within Likert scales. For instance, the pain level at the doctor's. When you go to the doctor and they ask you, how much pain are you in? You might answer with a 3. But that 3 doesn't really mean a quantity. It's really a label saying I'm in a little pain. And maybe my 3 and your 3 are completely different. You know, maybe I get a little bitty hangnail and I'm like, it's a 3. And you've broken an arm and you say it's a 3. So, you know, maybe our 3s mean different things. They mean how much pain you're in. But again, if you're in the hospital for several days, the nurse could look and see, oh, look how many 3s they said. How many 5s did they say? How many 9s did they say? And so they could count the number in each category, but they could also arrange those in a meaningful order. 9 would mean more pain than 2. So if I can arrange it in a meaningful order, then it's at the ordinal level of measurement. Both of these, nominal and ordinal, are what we can do with our qualitative data. We move up from there to our interval level of measurement. With our interval level of measurement, we're now looking at our quantitative data, that data that actually counts or measures something. So this quantitative data that can be counted, in other words, I can still see how many are in each category. I can arrange them in some sort of meaningful order, like I did back here. This is bigger than this, is bigger than that. In addition to that, I can see meaningful differences between the numbers. In other words, I could take and I could subtract and find out this one is that much greater than this one. So I can actually look at the differences between them. However, with our interval level of measurement, there's no true 0. So when I say 0 on something, it doesn't mean an absence of something. So let me give you some examples. For example, in temperature. In temperature, if I say there's a 0 temperature, it doesn't mean that the temperature doesn't exist. In fact, think about the difference between our Fahrenheit scale and our Celsius scale. 0 on both of those scales means something different. But we can count the number of temperatures we have in each category. We can arrange temperature in a meaningful order. This is hotter than that. We can find differences between the numbers. You know, I can say 50 minus 30, well, the temperature was 20 greater than the day before. But that true 0 is missing, because 0 temperature does not mean an absence of 0. That's also true with other scales that are just kind of made up, like the SAT scores. This is another example of that. If you take the SAT score and you don't, or take the SAT and you don't get a single problem right, it turns out that you don't get a 0. That's not the minimum score on the SAT. So that there's no true zero on an SAT score. And yet I can put them in a meaningful order. I can look at my SAT score and your SAT score and say yours is 100 points higher than mine. So there are meaningful differences between the two, but there's no true zero in those scores. So a lot of times our interval level of measurement, it's quantitative data or quantitative variables where the scale is kind of contrived. Last but not least, at our highest level of measurement, we have ratio level of measurement. And again, we're talking about quantitative data. In order for it to be at this ratio level, it must be a quantity. So we're collecting data that is a quantity. And it can be ordered as before. There are meaningful differences between our entries. But in addition to that, the zero indicates an actual absence of something. If I say there are 0 of them, it means there's nothing there. There's an absence of something. And because of that, multiplication can be expressed in a meaningful way. In other words, twice as many, if I have twice as many of something, it really truly means 2 times as much. Whereas like on an SAT score, just because your score doubles mine doesn't mean that you got twice as many questions right as I did. So here are some examples of that. Prices of car. If the that can be ordered, you know, this is greater than that, and I can actually find differences between that. You paid $100 more than I did. We can even say your car cost twice as much as mine did. So that multiplication actually is meaningful. And the big difference there is that we can see that 0 indicates an absence. So if you didn't pay anything for it, then there was an absence of an exchange of money. Or maybe there was just an absence of a purchase. Time is another example of that. If there's 0 seconds that happened, you know, how much time did it take you to run the race? 0 seconds. Well, then you didn't run the race. Ages, if you're, you know, not even born yet, then you've got a 0. There's an absence of age there. And height, if there's no height, then there's an absence of something. So, and in addition to that, all of those things can be arranged in a meaningful order. There are meaningful differences, and you can actually see multiples of those. With those levels of measurement, then we can begin to do some different math, and we can determine which type of statistic can I find for each of my data that I've collected. So for instance, if I've collected hair color, there are certain things I can't find. I can't find a mean average of hair color. I can't take your blonde and your brown and your black and add those together and divide. That doesn't make sense. The only thing I can do statistically is I can find maybe a proportion of my population that has black hair. Or I can find a percent of the population that has purple hair. So this hair color and gender and favorite pizza toppings, those at the nominal level, I can't find a mean for those things. So being able to tell the level of measurement helps me to determine which type of statistic I can actually find. But with prices of cars, I can find the mean. I can actually do some addition and division. And especially since there's that true 0 involved in that, I can find, means, mean averages. I can find all kinds of different statistics. We'll learn about those as we go along. But the level of measurement lets me know which types of statistics I can find for the data that I've collected. In this video, we're going to describe the variables in our scenarios. So in statistics, it's really important that we're able to describe our variables and our data that we obtain. So that then we know what math, what statistics we can find from that data that we've obtained. So we're going to describe our variables in a couple of examples here. Every time we describe our variables, there are 3 parts to describing the variables. First, is it qualitative or quantitative? Then, is it discrete, continuous, or neither? And the third part is the level of measurement that the variable is at. So first thing we need to actually do is decide what the variable is. What is the data that we are collecting? So let's read this first scenario and see if we can determine what that variable is, or what the data is that we're collecting. A sporting goods store is interested in determining the location of residence of their customers. The store asks every third customer to provide their zip code. So think about you being the researcher, the one that's collecting the data. What is your data going to look like? What is it that we're collecting from each of our customers? And it tells us that we are collecting from each customer the zip code. So here, the variable that we'll be describing is the zip code. The variable, or the data, is the zip code. Now we need to decide, is zip code qualitative or quantitative data? Remember that qualitative data is a category or a quality, whereas quantitative data is a quantity, it's a measurement, it's a count. Well, in this case, if I want to ask the zip code, I'm really just asking for my customers for the location of their home. Like when I give my zip code, it tells people that I live in North Temple. So that zip code just really means the location or that place of your home. And that's a category. So therefore, our zip code is a qualitative variable. So zip codes are qualitative variables, because it's just that location, because locations are a category. Then we need to know if it is discrete, continuous, or neither. Remember that these words discrete and continuous refer to quantities. We need a number in order to be able to decide if it is discrete or continuous. All of our qualitative data is neither. So because this is qualitative, it is neither continuous nor discrete. And then last but not least, the level of measurement here. The level of measurement is just nominal. We cannot do anything with these, our math. We can't do any math with zip codes. We can just count how many people are in each area of town. I can't really even put it into a meaningful order. Saying 76501 is not greater or less than 76502. Those two zip codes, I can't put it in some sort of meaningful order. So it wouldn't be ordinal, it would just be nominal. So zip codes there are just nominal data. And that tells me then later that when I'm trying to find my statistics, when I'm trying to do some math with it, I can't add these zip codes up and divide to find a mean. The only thing I can really do with them is find a proportion or a percent. Let's look at this other scenario. A factory manufactures pistons. The production manager wants to make sure the radius of the pistons meets specifications. The manager inspects 20 pistons from the production line. So think about what we're going to be. We're the ones inspecting, we're looking at it. What is it that we are recording if we're checking on the radius of the piston? We're going to be measuring that radius, right? So here the variable is the measurement of the radius. The variable is the measurement of the radius. And again, let's decide, is that a qualitative or a quantitative variable? Is it just a category, or is it a count or measurement? Well, we kind of gave it away when we described the variable, because it says it's a measurement. Since it's a measurement, it is a quantity. It's a quantitative variable. So, radius or measurement is a quantitative variable. We're going to record numbers. We're going to record a measurement. Then, is that discrete, continuous, or neither? Well, it is a value, so we are going to decide if it's discrete or continuous. When we measure things, a lot of times we can get more and more exact. So remember that discrete is a distinct or a countable measurement, whereas continuous is any number within an interval. And when we measure the radius, I could measure it more and more precisely. Maybe I measure it in centimeters or millimeters. I can get it more and more precise. And so therefore, this is a continuous variable. So the measurement can be measured more and more precisely, measured with more and more precision. Or you could find a radius in between. If you give me any two numbers, I can find a measurement in between those two. Can be measured with more and more precision. So the radius, so the variable is continuous. You need to be able to write with complete sentences when you answer these questions. Part of statistics is being able to communicate your findings. And so being able to write with complete sentences is important. And then last but not least, we need to decide on the level of measurement. Is it nominal, which means we can only count the things? Ordinal, where we can put it into some sort of meaningful order. Interval, where we can find differences between them, but there is no true zero. Or ratio, where we can pretty much do all the math with it. There's meaningful differences, addition and subtraction, as well as multiplication, and there is a true zero. So the first thing I do is I realize that it's quantitative. Since it's a quantitative variable, it's either going to be an interval level of measurement or it's going to be a ratio level of measurement, those two higher levels of measurement. Then I ask myself, is there a true zero or not? If I say my radius is 0, is there an absence of something? And sure enough, if the radius is 0, that means there's no piston there. There's an absence of a piston. So since there is a true 0, this is a ratio level of measurement. The level of measurement is ratio. And I can perform all math that I want to be able to perform on that level of measurement. So there are some examples of describing the variables. Anytime we describe variables, we're going to have 3 parts: quantitative versus qualitative, discrete, continuous, or neither. And then the third one is that level of measurement. Math Made Simple is Simpson Math. Thanks for watching.